Tonight we're learning about dividing polynomials and finding the roots of polynomials. When dividing polynomials, it's always possible to use long division, synthetic division is most efficient when dividing by a linear function. Linear meaning x minus 5. Okay, so since this is a linear function, I'm going to put the root in the box. List the coefficients, 1, 3, negative 5, 2. You bring down the 1, you multiply 1 times 5 and get 5. You add and get 8. 5 times 8 is 40. You add and you get 35. 5 times that, let's see, is 25. Carry the 2, 175, so 177. That's the remainder. So when I get done, I have x squared plus 8x plus 35 plus 177 over x minus 5. It was not a factor. It didn't turn out nice. Okay? Long division, ask yourself, what do you multiply x squared by to get 2x cubed? And you'd say 2x, because this gives you 2x cubed. That gives you plus 10x squared plus 4x, and you subtract. So this gives me 3x squared plus 15x, and bring down the 6. To get 3x squared, I'm going to multiply by 3, so I get 3x squared plus 15x plus 6. Subtract, you get 0. So there's one of the factors, and here's the other factor. Okay, that's your answer. Okay, the remainder theorem states that if a polynomial f of x is divided by x minus k, then the remainder r is f of k. What does that really mean? Well, here's the example. What is the remainder when you divide the numerator by x plus 2? Well, you put negative 2 in the box. Remember, it's always the root. Put your coefficients, 3, 8, 5, and negative 7. Bring down the 3. This is negative 6. Add. 2 times negative 2 is negative 4. That's 1. This is negative 2, and you add, and you get negative 9. This is the remainder. Okay? So what it's telling you about this function is f of negative 2 is equal to negative 9. Is that true? Well, let's plug negative 2 in. You get 3 times negative 8 plus 8 times 4 plus 5 times negative 2 minus 7. So negative 24 plus 32 minus 10 minus 7, I believe, is negative 9. All right, that's what the remainder theorem tells you, is that f of negative 2 is going to equal the remainder. That's a big concept. Got to think about that. All right, finding the roots of a polynomial. The rational root theorem says all possible rational roots of a polynomial are factors of the constant term divided by the constants of the leading coefficient. What we're looking for is possible roots. I don't have a calculator in my hand, and I want to know the roots of that function. Okay? If I do synthetic division with all these things, hang on, let me erase that. Synthetic division with 2, negative 3, 4, and 5, and get a remainder of 0, I found a root. Okay? But I need to know what to put in the box. That's where this comes along. And what they're talking about, the factors of the, let me clean out my mess. Okay? They're talking about the factors of this constant divided by the factors of the leading coefficient. Think about this before we do that. If this is a factor of a polynomial, you set it equal to 0 to find the roots. You get 2x equals 3, x equals 3 divided by 2. The constant divided by the leading coefficient. Constant, leading coefficient. Okay? That helps make more sense to me. All right, so here we are. The factors of 2 are 1 and 2. You put a plus or minus in front of them, because negative 1 times negative 2 is positive 2, and vice versa. The factors of 5 are plus or minus 1 and plus or minus 5. Now it tells us over here to take the constant divided by the leading coefficient. So 1 divided by 1, 1 divided by 2, 5 divided by 1, and 5 divided by 2. There's a plus and minus in front of every single one of them. And then clean it up. So this is plus or minus 1, plus or minus a half, plus or minus 5, or plus or minus 5 over 2. Those are the possible roots of my polynomial. It doesn't say that all of them are. There's 8 choices there. They're saying if I'm going to start out doing synthetic division, I'm going to pick one of those numbers to go in this box right here, and then do my synthetic division and hope I end up with a 0 for a remainder. All right? This one too. And all it says is list possible. It doesn't say find them. So you have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1, 2, 3, and 6. There's a lot of choices on this one. So I do it in order. 1 over 1, 1 over 2, 1 over 4. 2 over 1, 2 over 2, 2 over 4, 3 over 1, 3 over 2, 3 over 4, and 6 over 1, 6 over 2, 6 over 4. Remember, there's a plus or minus in front of all of them, and I cross out anything that's a duplicate. Like this is a 1. We already got 1 right there. 2 over 4 is a half. I already got a half. 6 over 2 is 3. I already got that. This is 3 over 2. Okay? It narrows down your choices. So your answers are these with a plus or minus in front of all of them. Alrighty? Now, you're moving on. You're going to use those lists to actually find the roots. So it's a state possible roots. Well, the plus or minus 1 is the first one. This is plus or minus 1, 2, 3, and 6. Okay, so I have 8 choices. And then I have to find the roots. Now, this is life without a calculator. This is pre-COVID. You're not at home using your calculator. All right? So what I would do is put 1 in the box. Put in 1, 2, negative 5, negative 6. Bring down the 1. That's 3. That's negative 2. Negative 8. Nope, that one didn't work. So then I'm going to try 2. 1, 2, negative 5, negative 6. Bring down the 1. 8, 3, 6. Oh, I was lucky. I found one. Okay, so one of my factors is x minus 2. The truth is usually you put in your calculator and find one of them and then do synthetic division to find the rest. Dang it. So now what's left here is x squared plus 4x plus 3. Because remember, these are the leading coefficients of your quadratic when you're done. That factors x plus 3 and x plus 1. And I also have x minus 2. So my roots are 2, negative 3, and negative 1. All right. Use division to find the roots, all the roots of this one. So I've got x squared minus 4x minus 1. I have x to the 4th plus 2x cubed minus 22x squared minus 18x minus 3. I'm going to start out by multiplying by x squared. I get x to the 4th minus 4x cubed minus x squared. Remember, you're subtracting, so I get 6x cubed minus 21x squared minus 18x. I have to multiply by 6. 6x, so now I've got 6x cubed minus 24x squared minus 6x. I'm subtracting, so I get 3x squared minus 12x. Bring down the 3. I multiply by 3 and get 3x squared minus 12x minus 3, and it's 0. Okay, but remember, I'm finding roots, not factors. So here I have x squared minus 4x minus 1, and other factor is x squared plus 6x plus 3. I can use the quadratic formula, or I'm going to do complete the square just so we practice. X squared minus 4x plus a box, minus 1 minus a box. Half of 4 is 2. 2 squared is 4. So this is x minus 2 squared minus 5, and I set it equal to 0. X minus 2 squared equals 5. Take the square root. Now I add 2 to both sides, and I have 2 plus or minus the square root of 5. Okay, this is x squared plus 6x plus a box, plus 3 minus the box. Half of 3 is 6. Half of 6 is 3. 3 squared is 9. So I got x plus 3 squared minus 6 equals 0. X plus 3 squared equals 6. X plus 3 equals plus or minus the square root of 6. And x is equal to 3 plus or minus the square root of 6. So there's 2 of my roots. Here's the other 2 roots. I have 4 roots because this is an x to the 4th. Remember, these are rational numbers. They're on the number line. They're just not pretty. Okay? Now it's time for you to practice.